In this video, we're going to look at the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is in reference to a quadratic in standard form with that ax squared plus bx plus c. When we plug into this, we have something under the square root, which is b squared minus 4ac. This is called the discriminant. This discriminant is important because plugging into just that b squared minus 4ac tells us how many x-intercepts or real roots or zeros of the graph. X-intercepts go by a lot of names. It tells us how many times we hit the x-axis. So if you think about a parabola, we have a couple different options for how many times it could hit the x-axis. So if your discriminant is positive, so positive, and I'm going to use just a capital discrim. A positive discriminant means that you hit twice. So you have a parabola that maybe looks like this. Has two x-intercepts. And I know that because I got a positive discriminant. Another option for our parabola is we could be touching and turning around at that x-axis. So if the discriminant equals 0, discriminant equals 0, that means we're just touching and turning around at our vertex there. We have one x-intercept. So two x-intercepts for a positive discriminant. For a 0 discriminant, there's just one x-intercept, or 1 0 of the graph, or one real root. If our discriminant instead is negative, that means there are no x-intercepts. We could have our vertex way up here and have a u, or maybe another option would be having a vertex below the x-axis down here, and then we go down from there. So negative discriminant has no x-intercepts. A 0 discriminant has one x-intercept, and a positive discriminant has two x-intercepts. So let's look at an example of calculating the discriminant, which is b squared minus 4ac. It's all part of our quadratic formula, and using it to determine how many roots we have for that function. So for this first one, we're going to first find the vertex. Well, first of all, I want us to think about what the shape is here. So A is 1 here. It's a positive A, so we're going to open up. We're going to find our vertex by doing negative b over 2a. So we have our a, b, c. So we're going to have negative outside of a negative 4 times 2, or divided by 2 times a. And now we have really 4 divided by 2, which is 2. I'm going to plug in 2 into the original function to figure out the y value of this vertex. So plugging into the original function, 2 squared is 4, minus 4 times 2 is minus 8 plus 4. So I have 4 minus 8 plus 4. My y value is 0. So my vertex is 2, 0. When I plug in 2, I get 0 for a vertex of a parabola that is going up on both sides. So how many times do you think we're going to touch that x-axis? If it's supposed to be shaped like a U, that should tell you it only touches that one spot at the vertex. But we're going to calculate the discriminant and make sure the discriminant agrees. Because if there's one x-intercept, our discriminant should be 0. So we're going to see what the discriminant is. The formula for the discriminant is b squared minus 4ac. B squared minus 4ac for this one is going to be negative 4 squared minus 4 times a is 1 times c is 4. So I get 16 minus 16. I do get 0. If it's 0 discriminant, there is one real root. We're touching the x-axis in one spot. And we're going to use the quadratic formula to find the real zeros. So we would plug in, there's a faster way to find the zeros because we already found it on the graph, but to verify we would do the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging into our formula, we're having negative b, which is negative of a negative 4. We have plus or minus that square root of b squared minus 4ac. We already calculated that. This is our discriminant. We already said b squared minus 4ac. That all is just going to be 0. Over 2 times our a is 1. So negative of a negative 4 is really positive 4. We have plus or minus 0, which isn't going to change the value, but we're just going to keep 4 in the top, over 2. 4 divided by 2 is 2. The x value, that is a root or a real 0 or an x-intercept, is 2, which we could already tell from the first part. So now we want to sketch the function. We already know where the vertex is. We already know the general shape is this u. But we could plug in some other points to see where the graph goes. So maybe we'll just plug in f of 0 to see what the y-intercept is. When you plug in f of 0 to the original function, you get 4. And we know this vertex is a line of symmetry. We don't have to draw these dots in. But I know that if it's going to be 1 over to the left and up at 4, it's going to be 1 over to the right at 4. 2 over to the right. We just want to make it look symmetric on that vertex. You could always plug in more points and see what the exact y values are. But here's our general sketch of this parabola. Something like this would be appropriate. Plugging in more points would only make a better picture, so it's never wrong to try to plug in more points on this. But there's our general U shape going through our vertex and some points that we plotted. Easier to do on paper than on an iPad. We're going to do that again, but there is our first example of finding a vertex, discriminant, and using those real zeros to graph a picture of the function.